Good morning, everyone. My name is Ajay Kumar. I'm a student of Leeds Beckett University. My student ID is 77468155, and today I will be presenting my project titled Disease Category Wise Early Prediction of Mortality Risk in COVID-19 Patients, which was supervised by Mr. Satish Kumar, who is my supervisor. And this research focuses on developing a machine learning model to assist in predicting mortality risk in COVID-19 patients with different underlying disease category. If you move forward on a aim and objective, my main aim of my research is to develop a predictive model to estimate the probability of mortality in COVID-19 patients based on their associated disease, and the objectives includes identifying key parameters from a healthcare dataset and investigating machine learning algorithm which predictive model really shoots for this. Develop, de- Deploying these models to generate actionable information, analyzing model result to support healthcare decisions. If I explain about the problem statement, COVID-19 has affected people very differently. Those with disease like diabetes, hypertension, or respiratory disease, or often face a higher risk of severe outcomes. This problem we address is predicting mortality risk earlier using machine learning. This allows healthcare providers to plan resources efficiently and intervene earlier for high-risk patients. On a slide number 3 about the dataset, for this project, I used an open source dataset from the Kaggle titled Global Health Statistics. I filtered the data for the UK and for the year between 2019 to 24. I specifically focused on COVID-19 cases. We specifically looked at the disease prevalence rate, health access percentage, treatment cost, and mortality rate. Then on slide number 4, methodology. Methodology has consist 8 steps: import of data visualization with the help of some scatter plots, heat maps, and pie charts or the bar graph to understand the data specifically, and finding the best key parameters in a dataset in order to build a model. On the next step, we will start the data preprocessing technique here with the data cleaning, removing missing data records, encoding data, and feature scaling with the help of normalization, standardization. Moving forward, we will split the data for train and test with the ratio of 70-30 and 80-20. After this, we will build the model even if regression model or a classification model. Then we will evaluate the model with the compute performance metrics and do predictions to make a better verdict. If you move forward on a slide number 5, if you see on this slide, I produced 3 visualization here to understand the average prevalence rate of COVID-19, and other is to understand the age group affected by COVID-19 categories in year 2019 to 24. You can see on the right hand corner like the age group affected by COVID-19. After it, on a slide number 6, understanding. To begin, we explore the data to understand trends across age group and affected disease category over time. I visualize prevalence rate through scatter plots and to make a more understandable, and I visualize prevalence rate through scatter plots and year-wise comparison. On a slide number 7, in this slide, the two charts have been presented which are about the health accessibility, prevalence rate, and mortality rate according to the category. Next one. Next one is our slide number 8 about the data pre-processing technique, handling missing values, encoding categorical data, removing outlier, and standardizing columns. These steps ensured how model would perform optimally with the clean in data. Next one, data analysis. Data analysis with represented by bar chart, line chart, and the pie chart. And these representations are giving information about the health access prevalence rate and mortality for category. And this chart consists 11 types of category, and I used pie chart also to analyze the data with more understanding or with proper presentation of data. Slide number 10. In this slide, I also try to create some scatter plots to analyze the insight about health access versus prevalence rate and health access versus mortality rate in with 11 category. You can see on the right hand all the categories available. Next one. Next one is about the model building. The model which I built in the linear regression. This had limited predictive ability with the R squared score of minus 0.04, and moderate precision and recall. And that gave me the accuracy of 44.85% of accuracy. You can see all the values here. Next, I tried to correlate the multiple feature in order to make a model more consistent, more specifically give best accuracy. Next one is a multi-linear regression. You can see the all values here. This also gave me the uh, little bit best accuracy as compared to the linear regression, but that was not really up to the mark for this project. Then I decided to move forward on our classification model. I started with the random forest. Random forest gave me the 52.20% accuracy. That was now also really not good, but surprisingly, this performed poorly with negative R squared and inconsistent result in a cross validation. Next one, XGBoost. XGBoost is my primary model, and this gave the best result. Initially, the test accuracy was around 46%, but after tuning hyper parameters like learning rate and mixed depth, we reached to 77.8% accuracy on data. If I take you to my Jupyter notebook where I performed all these things, all the codings here, you can see here. First of all, I import the all important library here to make a and then I load the data here. You can see on the screen. Then in the cell number 3, you can see the long columns. The long columns are replaced with a shorter, more meaningful ones for easier than and make easier for to make a to do a pre-processing. After that, I filtered the data with the COVID-19 and UK based, and I chose the COVID-19 cases only and the year from 2019 to 24. After that, you can see. After that, I select the features and the target variables here. You can see my features are independent variables are health access, prevalence rate, and average treatment cost. And if I say about my target variable is mortality rate with the um, with a cutoff of 5%. And after that, I split the data with the 80% and 80% for training and 20% for testing, with the random state 42% for better results. After that, you can see in a cell number 6, I applied here normalization here to transform the data in a to rescale the value. Then after that, I applied here implementation of gradient boosting here. This was the first initial model training before XGBoost. Then if you can see all learning values here, then you can see all the results which I got during the running of this code. Then if you can see, then I also split the data with the 80% and the 20% ratio. Then I implement the XGBoost model here, and I got the accuracy of 0.426%. That was not really up to the mark. Well, in order to improve the accuracy, so I decided to go with the hyperparameters tuning. Because hyperparameter tuning is help to improve the performance and accuracy of model. You can see all the parameters which I applied in the hyperparameter tuning. Then if you go to the results which I got during my experiments, so 47%, 50%, 44%, that was not really up to the mark. So then I implement the learning rate here with the values of 0.0.0522, and I got the accuracy with the average learning rate 0.52. So if you can see on the learning rate one, that was the highest accuracy which I got. So then I trained the model here, and this is my accuracy of this model. And my primary model is XGBoost model. So these all the values which I got during my experiments. And if I talk about challenges, so during this project, I faced so many challenges to understand the data because it was too much big data to understand which variable should I choose for this project. And choosing an accurate model as low accuracy score I was getting during the experiments, and data quality handle missing values. And if I tell you about the future work, so I'm thinking to improve the model with the deep learning techniques, use more real-time patients data, and to create a tool for hospital use. add features like vaccinations or locations, and these kind of feature we're expecting to do it. And so this is the all presentation of my dissertation project, and I'm looking forward feedback and Q&A.